Okay, short video on vector geometry. And we're going to have 2 points, P and Q. So P is at 2, 1. And Q is at 3, 5. And we want to find the vector PQ. Admittedly, you could probably look at the coordinates and just work that out, but I want you to move away from using coordinates and into working with vectors as well. So just thinking back to the PowerPoint you did last lesson where you were travelling along vectors to get to different places, that's what we need to apply here. So we can turn a coordinate into a position vector really easily. So the position vector of P is equal to 2, 1. So long 2 up 1. And the position vector of Q is equal to 3, 5. An alternative notation for that is lowercase p and lowercase q. So to get from P to Q travelling along vectors, we can go from P back to the origin, and then from the origin to Q. So the vector PQ is equal to going from P to the origin plus the origin to Q. Going from P to the origin is the same as doing minus OP. So OP is that way, minus OP takes you back that way. And so PQ is equal to the position vector of Q minus the position vector of P. And that's kind of one that's worth remembering. So it's the position vector of the second one minus the position vector of the first. And you could write that using that lowercase notation as well. So to find the vector, it takes us from P to Q. We're going to do position vector of Q, which is 3, 5, minus position vector of P, which is 2, 1, and that gives us 1, 4. And then if you wanted to find the length of the vector PQ, so finding the magnitude of PQ, remember that's just Pythagoras. So we just do the square root of 1 squared plus 4 squared, which is root 17. So to start with, if you could have a look in your books, page 259, so your class books. Question 2, part 1. I think one of those is probably enough. Question 3 and question 4. I'm going to go over question 4 at the beginning of my next video just to make sure you're okay with that.